Thank you all for coming, and a special thanks to the Mann Foundation for their ongoing generous support of early childhood. I'll talk about synchrony, emotion regulation, and the neurobiology of attachment, the foundation laid in the first 3 years of life. And I'd like to open with a quote from John Bowlby, the father of attachment theory, in an old manuscript that was never published when he was working with war infants in London and first formulating his opinion about the centrality of attachment relationships. The roots of parenthood lie in the child's relations to his own parents in his earliest years. The love which a mother has for her children is a reflection of the love which she received when she was a little girl. The love which a father has for his children is the reflection of the love which he received when he was a little boy. It is in childhood that we learn to love. And what I hope to show you today is how we learn to love in childhood. What are the specific behavioral patterns, hormonal system, brain networks that become activated in the parent right after the birth of a child? How these are transmitted to the infants through synchronous interactions, and how these interactions set forth the infant's capacity to love, and through such love, the capacity to self-regulate, to empathize, to symbolize, to aspire. What is attachment? Attachment are meaningful relationships, and they have two components. They are selective and they are enduring. Selective refers to the exclusivity component in the relationship. It's a relationship between only me and only you. Enduring means that these relationships are long-lasting, often a lifetime, last long enough to be meaningful. Because attachment bonds are so critical for survival and continuity of life on Earth, they have highly specific and conserved genetic, behavioral, hormonal, and brain components. There are three prototypes of bonds in mammals. There is parental, the parent-child, child-to-parent. The pair bonds are romantic attachment, and the filial, which in human refers to our relationship with our close friends. And they all share underlying mechanism related to the oxytocin system. But the parent-infant bond provides a template for bonding throughout life. Across mammalian species, the parent-infant bond provides the setting through which young become members of their social world and learn the rules of social exchange. Human infants also learn the core social phenotypes required to navigate the social world, our social world, behaviors such as turn-taking, frustration tolerance, understanding the minds of others through processes of bio-behavioral synchrony. And what is synchrony? Biobehavioral synchrony is defined as the coordination of biology and behavior between attachment partners during social contact. In all mammals, and it's important to say that being born a mammal implies that the brain is not fully mature at birth and develops in the context of the nursing diet. So in all mammals, the parent's mature physiological systems can externally regulate the infant's immature physiological systems through the coordination of social cues during moments of contact. So in human, we found that during moments of face-to-face interactions, parent and infant coordinate their behavior in the gaze, affect, vocal, and touch modalities. Those coordinated behavior provide a template for biological synchrony between the parent and infant, heart rhythms, for coordinated release of oxytocin, and for brain-to-brain synchrony between critical nodes of the social brain. Maternal synchrony, maternal infant synchrony begins right after birth with the rush, and it's triggered by the rush of oxytocin during childbirth. So all mammalian mothers begin right after childbirth to express the species-typical repertoire of maternal behavior. In humans, these are four behaviors. Mothers gaze at the infant face and body. There is positive affective expression. There is motherese high-pitched vocalization, motherese, so parentese high-pitched vocalization, and affectionate touch. Touch that only intends to transmit love and doesn't have any functional purpose. But in humans, more so than in other, or unlike other mammals, that there are also two additional components. First, human mothers coordinate the expression of these behavior in the first day of life with the infant signs of social readiness. So in health, already in the first day of life, infants feel a match between their own state and the caregiver's response. And the second uniquely human thing is that relates to touch. All mammals, bonding occurs in a context of parent-infant touch. In humans, touch is integrated into the visual, affective, face-to-face signals. So from the time humans are 3 months old, they can impact the physiological system of another human through the coordination of visual, affective, facial cues. At around 3 months of age, infants begin to take active part in social interaction, and this starts to form the unique dance between each parent and child with its own rhythm and tempo and dynamics. Such interaction have two important outcomes. First, they enable biological synchrony between the parent and infant physiological system. And second, they carry long-term outcome across childhood, adolescence, and even up to adult life. It is important to say that not only mothers synchronize with their infants. Father can synchronize with the infant too, to the same degree, but in a different way. So that mother-infant interaction, mothers cycle between state of medium and low arousal at a fairly predictable pattern, and there is one high peak of positive arousal, which is framed by social gaze. I got to show you the fathers quickly. Fathers have a very different pattern of interaction. Their interaction contains very quick peaks of positive arousal. It's not directed to the infant face, but to exploration of the environment, and those peaks come at random. In health, an infant should be able to experience both synchrony with mother that establishes the rhythm of safety, and synchrony with father that establishes the rhythm of excitement and exploration. In several longitudinal studies that are running in my lab, we follow the development of synchrony from birth to adolescence, and this is our longest longitudinal study. We're seeing these children from birth to 22 years. Here you see Maya. I'm sorry, the last picture is not her, but all the others are. She'll be coming in a few months. And what we found in all those longitudinal cohorts is that synchrony has a sensitive period. You must experience that rhythm of safety, that dyadic synchrony during the first 9 months of life. And then later ability kick in, but just like the 12-bar blues, you keep on playing that rhythm of safety where the right hand can improvise more and more complex music on the basis of that safety. And this is how it happens. In the newborn period, there is the expression of the species-typical parental behavior. In the first year of life, there's the coordination of nonverbal behavior in the gaze, affect, vocal, and touch modalities. In the second year of life, there is a joint symbolic play between parents and children. In preschool, there is the co-construction of narrative, joint imagination, joint internal state talk. These developments lead in adolescence to a host of positive outcomes: empathy, executive functions, stress management, the capacity to dialogue conflict, and lower psychopathology. When we looked at the mechanisms by which early synchrony predicts developmental outcome in adolescence, we found two mechanisms. First, there is a step-by-step continuity so that better synchrony at one stage leads to better synchrony in the next. But there is also direct continuity between synchrony experienced in infancy, in early infancy, in the first months of life, and adolescent outcome, highlighting the critical importance of synchrony in the first months of life. Interestingly, in those 10 times that we followed children from infancy to adolescent, we also measured emotion regulation. And emotion regulation also has a developmental trajectory from physiological regulation in the newborn stage to emotion regulation in infancy to attention regulation in the second year and self-regulation in the preschool years. And interestingly, those predicted the same developmental outcome in adolescence using the same step-by-step mechanism as well as direct continuity from infancy to adolescence. We then use some complex mathematical modelings, and we found that there is a cross-time mutual influences between emotion regulation and synchrony and emotion regulation. So that better synchrony at one stage leads to better emotion regulation at the next stage, leading back to better synchrony at the third stage, and vice versa. And those mutual influences between synchrony and emotion regulation set the trajectory of development on a more optimal path. What is the physiological system that supports our capacity to engage in synchronous parent-infant interaction or human-to-human interaction? And this is the oxytocin system. What you see on the left is that oxytocin is a neuropeptide hormone mainly produced in the hypothalamus, which is deep in the brain. It branches out in two directions, one into circulation and one into the brain. And I think there are three important features of the oxytocin system that are important in the context of early development and intervention. The first is what you see on the right, that oxytocin is a highly integrative system. Not only that it crosstalks with several systems in the brain, with the extended amygdala system, with the dopamine reward system, but also there are receptors for oxytocin throughout the body in many body organs. So oxytocin integrates body and brain, organism, and environment. The next feature of the oxytocin system is that it is a very ancient molecule. It is thought to evolve from gene duplication in jawed fish approximately 600 million years ago, and is found in all vertebrate and some invertebrate species. Now, interestingly, in all species from nematodes, lizard, or fish to humans, oxytocin implicated in basic life functions that aim to manage stress, such as water conservation or energy balance or thermal regulation. But these functions have been repurposed so that oxytocin became supportive of social function. So that oxytocin across all species evolve so that the organism can use social relationship to manage the stresses involved in harsh ecologies. So oxytocin is the perfect system to help an individual manage stress. And the third feature of the oxytocin system is that it functions in the brain as both a neuropeptide as a hormone. That means that it integrates the temporal precision of as a neurotransmitter as a hormone. So it integrates the temporal precision of a neurotransmitter with the long half-life and the ability to function at faraway location in the brain of the hormone. And this unique form of peptidergic release causes the oxytocin system to reorganize brain network on the basis of early attachment relationship. Now, how the oxytocin system impacts early development and parent-infant bonding? Well, it's very difficult to summarize 15 years of research in my lab on the topic in 3 minutes, but I'll try to highlight just 3 important features that are relevant for today. First, we were very surprised that fathers, even though they don't give birth and they don't nurse, which are the major source of oxytocin release, in the first months of life already, fathers have similar levels of oxytocin to that of mothers, even when mothers are nursing. And it's very interesting that there is an alternative pathway. So while mother's oxytocin increases by birth and lactation, father's oxytocin increases through active participation in child rearing. So there are alternative pathways. You don't need to be a biological mother. Second thing is that oxytocin is released after touch, contact, and synchrony, not only between biological parents, but also in foster parents, or we find it in 3-year-old children after interaction with their best friend. Third is that other period of bonding in human life, such as when you fall in love, are associated with dramatic increase in oxytocin, which is also linked to synchronous interaction between romantic partner. And the final point, which is relevant for us today, is that conditions associated with disruptions to maternal infant, to parental infant bonding, such as maternal postpartum depression, premature birth, or high contextual stress, are associated with shutdown of the oxytocin system and no oxytocin response to social contact. And because the oxytocin system functions as a biobehavioral feedback loop, where more touch and contact releases more oxytocin, and more oxytocin triggers more behavior, this should spell danger, because those kids' oxytocin system is not responding to social interaction. Well, the last component in the trilogy of the neurobiology of parenthood, behavior, hormone, is the parental brain. Now, it's more important to say that there is no other period in adult life when the brain is so plastic as the period after you have a child. Research on the mammalian brain, the mammalian parental brain, is already 60 or 70 years old, but only in the last 5 to 10 years, we're looking at the human parental brain. And what we found is that the human parental brain is underpinned by the same subcortical system as the mammalian parent brain, including the oxytocin-producing hypothalamus, the amygdala, which tell us, be aware, be vigilant, be preoccupied, maybe there is danger to your infant, and the dopamine reward system, which allow parents to draw reward from their infants. But in humans, unlike other mammals, this subcortical system is connected via multiple ascending and descending projection with several cortical systems that form together the human parental caregiving network. This includes the empathy network that enable parents to feel the pain and emotion of their infant and ground experience in the present moment. The mirror network that enable parents to represent in their own brain the infant action. The mentalizing network that enable parents to understand the infant intention. And the latest evolving emotion regulation network that enable future planning and goal-directed caregiving. Altogether, they form the human parental brain. We were interested in 2 questions. First, how synchrony is implemented in the parental brain. So we recruited a large group of mothers. We measured their behavior. We observed and microcoded their behavior. We divided them to synchronous mothers and to those who were overly stimulating and intrusive mothers. We then put them in the imaging machine and measured their response to their infant video. We found that there were 2 areas that showed difference between the synchronous mothers and the intrusive mothers. Synchronous mothers had much greater nucleus accumbens activation, which is part of the dopamine, subcortical dopamine pathway. They drew a lot more reward from the infant, and intrusive mothers were much more anxious. They had much more amygdala activation. We then looked for functional connectivity. What else in the brain works together with these 2 subcortical structure? And we found that among the synchronous mothers, the entire human parental brain was working alongside this nucleus accumbens, whereas in intrusive mothers, nothing was modulating the intense amygdala activation. So synchrony is implemented in the brain by an underlying reward coloring and connected to the entire human abilities that enable the parents to empathize and mentalize and provide adequate and attuned caregiving to the infant. And the last study I want to show you asks the question, what are the developmental consequences of the parental brain. If we look at the human brain as the apex of evolution, and the parental brain is the most plastic period of that apex, does that have any implication for children's development? Okay? So we followed those children 3.5 years later, and we now have 4-year-old children. We went to their home, and we measured them with the experimenter, not in the context of their parents. We had several emotion regulation paradigms: socialization through a toy pickup paradigm, regulation of negative emotion through a fear mask paradigm, and regulation of positive emotion through a soap bubble play paradigm. And what we found is that children whose parents had greater coherence of the mammalian subcortical unconscious caregiving network had better regulation of positive emotions. Those kids were better, expressed more positive emotions and used the other person to enhance positive emotionality. Children whose parents had greater coherence of the empathy network 3 years before were better able to regulate negative emotions. They expressed less negative affect, and they used diversion tactics to regulate the fear paradigm. Children whose parents had greater coherence of the mentalizing network were better able to express self-regulated socialization. Now, this is important for 2 reasons. First, it's the first evidence that what's going on in the brain of one human can longitudinally predict the behavior 3 years later of another human in a different context, not with a parent. But it is also important because when we see the brains of depressed mothers, stressed mothers, traumatized mothers, we don't see any brain response to their infant cues, which means that this places their children at much greater risk for social emotional development. So just to conclude, bonding is a process through which the physiological and social signals of one partner synchronize with those of the attachment partner. The extended oxytocin pathway plays a key role in this process. Conditions associated with early stress and trauma blunt the oxytocin system and disrupt parent-infant synchrony. And finally, something for us to do as clinicians and educators. Because the oxytocin system is open to environmental influences, intervention that focus on enhancing touch and augmenting social synchrony can reverse some of the effect of severe stress on the developing brain. Thanks to my students who carried out this study, thanks to our funders, and thank you for listening.